Assalamualaikum warahmatullahi wabarakatuh. As we have promised before, now we are continue on the next part for Gametogenesis. This chapter or this part is mainly for female oogenesis, means the ovum, how the ovum are developing, and what are the process involved there. So oogenesis. So in the ovary itself, it is the main part where oogenesis are taking place. So as what we have learned in spermatogenesis, they do have germinal cells. This is the same for ovary. They do have germinal cell which are diploid, 2N, and then it will undergo mitosis directly to produce primary oocyte, which are also diploid in number. And then they do contain two processes of meiosis 2, meiosis 1 and meiosis 2. And we will learn on which part that are undergo polar body, and then where oocyte and the ovum are produced. So basically, during meiosis 1, primary oocyte will be dividing into two types of cells. First one is what we call as polar body, and secondary oocyte, which is now from diploid turn into haploid. So they are again undergo a second meiosis, which are meiosis 2, and then they are having a second polar body, and the ovum now are generated, which are most of the ova are majority of the ova are haploid in number. So this is all about the egg, but we do have also has to know about the container of the ovum itself, what we call as follicles. The follicles also here are developing. Each one from they are developing to from a small into a mature follicle, and then if ovulation occur, so the follicle will be ruptured, leave only oocyte there, and then the follicle then will be ruptured, and now we are calling them as corpus luteum. So this is the overview of the illustration for the whole process of oogenesis. So oogenesis, we do have for women, it's only a total supply. There's no division, no additional eggs. Okay, if it is present at the birth at this the same amount of egg, so it will continue throughout the life with the same number of the eggs. So this is what we call as total supply. Then they do have ability to eggs to be released only begins at the puberty, and then it will ends at menopause. So this is what we are what are the differ from male, because male do not have menopause, but for women they do have menopause. So the ability means stop here. Oocytes are matured in developing ovarian follicles. What we have the container, right? The the container of the oocyte and so on. So then during baby girl baby girl during their fetus, the oocyte are not called as oocyte, they are called as oogonia here. What we call as germinal cells, which are diploid. Oogonia will undergo mitosis to produce primary oocyte after 2 to 9 months of gestation. So here means after this here are developing during the fetus inside the mom's womb, and then primary oocytes, okay, are after 2 to 9 months of gestation. So this is where the primary oocyte means 2 to 9 months there inside the mom's wombs also, they are developing into primary oocytes, which also are diploid in number. Primary oocytes are surrounded by cells that form primary follicles in the ovary, and then this oogonia no longer exists after the time of birth. Means here this these two phase are only applicable during the baby girl are inside the mother's womb. Baby girls inside the mother's womb. So they stop here. So now after they are giving birth, primary oocyte will develop into meiosis 1 and meiosis 2. So after that we can see. So oogenesis here. This is the also illustration for oogenesis. So as an embryo antimonopause, the number of the cells are only there. So ovaries are the places where this oogenesis occur, and then these are all the genetics chromosomes that were carried by the germ cells with all diploid in number, or gonium also diploid in number, primary oocyte also diploid in number. And then between birth and puberty, they are entering prophase 1 of meiosis. Okay, means here during the baby, after the baby are giving birth, okay, then until it is childhood, and maybe before puberty is almost 8 years old of a girl. So the one that primary the meiosis only start for prophase 1. The the primary oocyte, the mechanism of oogenesis only the meiosis of prophase 1. Okay, and after puberty, okay, the onset of puberty, the one the hormone uh, control FSH, okay, will be released. Okay, will be released, and this hormone trigger the completion of meiosis 1. Means from prophase, anaphase, metaphase, and so on, they are directly released after meiosis 1. After meiosis 1, they are is, but where, okay, when the secondary oocyte and polar body, okay, secondary oocytes are now called as, we do have secondary oocyte as first polar body there. Okay, this is every cycle of the meiosis 1. Only meiosis 1, the what we call as period happening and so on. It's also it's the onset of meiosis 1 from prophase, anaphase, metaphase, and telophase. So this is occurring every month of the cycle for menstrual cycle, and they do have secondary oocyte. Once they are getting married and so on, so then now meiosis 2 are taking place, means after they are married. Okay, the second meiosis 2 are taking place there, and this is mainly stimulated by the fertilization. So now they are producing one ovum and second polar body. So this is the phases of life before birth that are having the oogonium development from mitosis, and they are growing until the childhood. The childhood only until prophase 1, and they are arrested on at birth, and then they are still there until now the onset of what we call as puberty. During puberty, the FSH are calling for the meiosis 1 to complete the cycle. Okay, and it is one primary oocyte for 1 month. Okay, so they are having for the meiosis 1, and then they are, if they are getting married and have fertilization of the sperms there, so the process of meiosis 1 will continue into process of meiosis 2. So this one may or may not occur, means sometimes you can see a lot of factors and so on, but if there's fertilization between sperms and ovum, so they are completing meiosis 2, and now the process will be complete until the they are giving birth. Okay, so this is about the follicles that should be known. Each females are having 400,000 of primary follicles in her ovary at birth, and a female starts producing eggs at puberty and cannot possibly produce more eggs than she has follicles. And if there's only if there are 400,000 of primary follicles, but for the entire life, it's only 400 mature age of her lifetime. And every month, the ovulation will be occurred where the egg or the ovum itself will be released from the ovary throughout the fallopian tube and so on. Okay, so this is the development of the follicles itself, from primary follicles go to growing follicles, and they do have the egg cells with follicular cells, a lot of it, to nourish the cells itself. And by the time the follicle will be matured. And then during ovulation, okay, the follicle will be ruptured, but releasing only an egg, okay, an egg for 1 month. So this is what we call as ovulation, and the empty follicle will be ruptured, and now we are called as corpus luteum. Then corpus luteum will be regressed, and if there's no fertilization occur, so it will undergo menstruation. Okay. So the same illustration here, how's the primary germ developing into meiosis 1 after the onset of puberty, and then meiosis 2 if there's fertilization occur, from oogonium going to have a secondary oocyte that are ovulated and so on. We do have oocytogenesis. Oocytogenesis is a transformation of oogonia into primordial cells. Okay, this is complete prior to birth. These are what we call as from primordial germ cells. It's developed into, this is what we call as the stem cell, turn into oogonia. Then prior to birth, after giving birth, this stop here, and primary oocytes are there. Primary oocytes will undergo prophase 1 only. Meiosis till only prophase 1, only till prophase 1. And this is stopped until the puberty occur. So primordial follicles are the primary oocytes. Okay, we go to meiosis 1. Meiosis 1, after primary oocytes are there, so they are undergo meiosis 1. So meiosis 1, ovaries are producing gametes and sex hormone, and oogenesis mostly of should be occurs in ovary. Oogenesis begins with the development of oogonia, become primary oocytes during prenatal development, and primary oocyte and cells surrounding to form a follicles. So follicles is to support and nourish the gamete cells. So primary oocytes are inactive until puberty, and this one should be arrested at prophase 1, only prophase 1. Each month, each month means during puberty, primary oocyte will complete first meiotic division, means from prophase 1, they are entering to anaphase, metaphase, and division, and forming secondary oocyte. So means all the meiosis 1 is complete. Meiosis 1 is complete for every month of cycle. And then follicle stimulating hormone H cause primary follicle to mature, and meiosis starts inside the maturing follicle to produce secondary oocyte and the first polar body. So means here, the one who are responsible during puberty is this called FSH. Okay, they are stimulating primary oocyte there. Primary oocytes now becoming secondary oocyte. Okay, why? Because they are already completing all the processes of meiosis 1. And these are occurring inside the maturing follicle. Inside a maturing follicle, and these are happening 1 for 1 month. So this is the meiosis 1, an overview from prophase, metaphase, anaphase, and telophase. So you should bear in mind that during prophase 1, this is stop after the girl are giving birth. Okay, stop here. After they are giving birth by the mother, so it's only stop at prophase 1. Means they do have sister chromatid, plasmata spindle, and so on and so on. So after FSH stimulate the oogenesis, then they are completing the metaphase 1. Metaphase means they are all at the metaphase plate, and then anaphase 1, where they are separated into each every end of it. So, and telophase where the cleavage furrow are performed. Okay. Then meiosis 2. Meiosis 2 are occurring, okay, after fertilization. Okay, we should bear in mind when we are talking about meiosis 2, it is after fertilization. The first polar body may undergo further division. Either event of the polar bodies ultimately disintegrate. Secondary oocyte remains in meiosis 2 until metaphase 2 only, okay? Metaphase 2 until fertilization. Okay, means here, fertilization are completing into anaphase and telophase. After fertilization, they are having anaphase and telophase. So, secondary oocytes will remain there until metaphase 2 only. Until metaphase 2 only. Okay, not metaphase 1. This metaphase 2 because we are going to see into metaphase 2 only here. So this is where meiosis 2 are occur. But after fertilization, they are undergo meiosis 2 and enter anaphase 1 and telophase. Anaphase 2 and telophase 2. And meiosis 2 is complete after ovulation if only sperms penetrate or fertilization occur, and oogenesis results in one haploid ova. One haploid ova. This is fertilization occur. They are completing the cycle of anaphase 2 and telophase 2. So now we are moving into the production of secondary oocyte. Secondary oocyte there. Okay, each cells do have follicles. Okay, follicles. This is the follicles. Follicles which are, okay, this is the whole structure of the follicles. The whole structure of a follicles. So the follicles do contain fluid. They also secrete fluid as well as estrogen. This one is very crucial for giving the nutrition and so on to the developing eggs. Typically, one follicle will mature fully for 1 month. Secondary oocytes is ejected from follicle during ovulation, and remaining follicle cells from the corpus luteum. And corpus luteum actually is a temporal, means not temporal endocrine organ that also can secrete progesterone as well as estrogen. Means here, not only the ovary itself can secrete progesterone and estrogen, ovary, okay, but they do have this corpus luteum that also temporarily can secrete progesterone and estrogen. Okay, this is the microscopic view of secondary oocytes inside the follicles. The follicles do a lot of layers from theca interna, theca externa, and from the secondary oocytes are resides at the most inner part. We do have corona radiata, another layer of granulosa cells, and cumulus ovorus. And then we do have another zone, what we call as zona pellucida. This is the um, the overview on only one ovum that are tried to be fertilized by, I think, hundreds, thousands of sperms. Okay, so now we do have to take notes that the oocytes is only viable from 12 to 24 hours only. So means only 1 day for a possible fertilization to occur. Means where it is 1 day to fertilize. But for sperms, they do have longer time from 12 to 48 hours. And for 2 days, they can reside inside the wombs after ejaculation. And this is, by the way, to give more extension of time to take their way to uterine tube for fertilization to be possible. This is the macroscopic overview of secondary oocytes that do have its second polar body, and they are resides inside a zona pellucida, and a lot more of another layers of secondary oocytes there. So we do have what are the differences between cell types, the process and time of completion. We do have oogonium, which are complete after third trimester, meaning after 8 months inside the gestation. Primary oocytes also deployed in number. In first phase 1 until ovulation, means this one is during after birth until the childhood. And then the secondary oocyte after they are matured. Okay, this is halted in only metaphase 2 until fertilization of meiosis 2. Otid is haploid, and this complete of minutes after fertilization, and then ovum also haploid cells. So these are what differences between spermatogenesis and oogenesis. Spermatogenesis, we do have both have stem cells that continue. This is the same, the spermatogenesis and oogenesis. Spermatogenesis produce 4 gametes, but for oogenesis only 1 gamete. Okay. Meiosis are beginning at puberty. Meiosis are beginning in fetus, but they are delayed for years. Meiosis has been begin, but they are wait at only phase 1. Okay, then differentiation of gamete occur while haploid, means even they are not yet uh, complete, but they directly occur what we call as spermatid. But the differentiation of gamete for women only occur if they are diploid, means once fertilization occurs. So the differentiation only just start there. Okay, why? Because after fertilization, they will developing into zygote and so on. We'll have a complete number from N plus N of ovum and N of sperm to produce diploid cells of progeny. Okay, so we have completed. We have completed the discussion regarding this topic. So now after this, we will continue again and see you again for the next topics. Bio 595. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.